Before we move on, we'd like you to pause and take a quick one-question survey that just asks how comfortable you are using CRA in your classroom. You can find the survey by clicking on the link in the slideshow, or there's a link on the Google site. Please take a moment and do that now. When we teach new math concepts to students, we often jump right into teaching them in the abstract phase. In other words, we're teaching them using the numbers and symbols that we're all used to seeing when looking at math. But for students who have difficulty learning math, and for many others, this is really difficult. One way we can help them understand conceptually what's going on is by using concrete manipulatives or pictures that represent the abstract numbers that we're used to seeing. By spending some time in the beginning teaching students conceptually what's going on, later on, it's going to be much easier to teach them how to do a procedure using mathematical symbols and numbers. For example, on the left-hand side of the slide, we have some concrete manipulatives. And on the right-hand side, we see what the manipulatives would look like if you were to use abstract numbers and symbols. CRA stands for Concrete, Representational, and Abstract. Concrete is the use of manipulatives that represent math concepts such as numbers and geometric shapes. Representational means drawings or pictures that represent concrete manipulatives. And abstract means the numbers and symbols we are used to seeing in math, such as numerals, plus signs, and so on. It's important to remember to always be connecting the concrete and representational to the abstract symbols and numbers. So if you're teaching students using concrete manipulatives, you would also want to write out what those concrete manipulatives mean in numbers and symbols. For example, if you're doing a problem with fractions and you're using two colored sided dots to represent the fraction, you would also want to write out what the fraction is using numbers and symbols so that students are always making the connections between the concrete and representational to the abstract. Some of you may be asking, why CRA? Because CRA is research-based and it's been found to be very effective for students of all ages, including adult learners. CRA can even be applied to other disciplines, such as science. Imagine trying to teach a child about an atom without providing a concrete model or visual representation. What would the child think that an atom looks like? Do you think they would come up with the picture seen here on the slide? Or do you think they'd have a really hard time coming up with what it looked like at all? Having a model really helps that student conceptualize what an atom looks like. You can think of CRA like chess. You can learn how to play chess really quickly, but it takes years of thoughtful practice to really master it. CRA is no different. It's really easy to learn, but it can take a long time to master it in your classroom, and that's okay. Earlier, we looked at formative assessment. Using formative assessment, you can help understand what phase of the progression students are in with CRA. So by doing constant formative assessments, you'll be able to tell if your students are ready to move on from the concrete to the representational phase, or are they ready to move on from the representational phase to the abstract phase? Or do your students need to maybe have some more time in one of the earlier stages of CRA? Maybe some of your students are ready to move on and some others are not. Using formative assessments will help guide you on whether students are ready to move on or not. Next, we're going to take a look at how you know when students are ready to transition from one step to the next and how you might go about that in your classroom.
Once you have a foundation in the CRA progression and you can start applying it in your instruction, you'll start to wonder about where your students are and how they're doing with the concrete, representational, and abstract steps. And we're going to focus now on assessing where students are in the progression and how to help them move between and across the different representations. As students transition through the progression of CRA, it's easy to think about them leaving one step and moving fully on to the next step. We often think of CRA with this visual that shows each step as a distinct and standalone step that students move between. However, this doesn't really show the full picture. Really what's happening is more like this. Here, each phase isn't independent from the others, instead they're layered in a continuum. Instead of moving from one to the next, students are adding on additional representations as they gain better understanding. They can kind of move between these. Without a firm understanding in the concept, though, here in the concrete, they can't really move forward to the representational and add that on. And the same with the abstract. They really need these firm, concrete, and representational understandings to understand the content that they're learning before they can really start to apply the procedure. Some people like to think about CRA using this visual, where students move fluidly between each representation for different concepts. What's great about this visual is that it really reinforces what research has shown about using multiple representations. Comparing and contrasting between the concrete, abstract, and representational versions of the math problem that they're working on really solidifies and deepens their understanding. Using multiple representations can also include comparing two concrete representations, two pictorial representations, or two abstract representations, and any mix thereof. The more versions and representations that they're able to compare, the deeper their conceptual understanding will be, and later they'll be much more flexible with the procedures that go along with the math concepts. Now, how do you do this in the classroom where you have students all over the place at different stages of their understanding, or even with a small group of students who are struggling? Let's watch this video of a math specialist who is going to explain how to keep groups of students moving through the progression. And then we'll talk about how formative assessment can help you make sure that your students are making progress.
Another way to think of CRA and it happening simultaneously versus sequentially is I want you to think of time, this x-axis, as time. Time is ticking, and time might be days, weeks, months, or years. And I want us to think about, okay, we're teaching a concept, and initially we might teach that concept through concrete. We've pulled out the manipulatives. Everybody is building, using those manipulatives to understand the conceptual understanding that we want to get them to. And eventually what's going to happen, time will be going on, and a student is going to come up to you and say, really, do I have to keep building with these cubes or these base 10 blocks? And you say as the teacher, I don't know, do you have something in mind? And the student will say, well, yeah, instead of me using the manipulatives, can I just draw a picture of them? And you say, wow, that's pretty lazy. Go ahead. And now the student is pushed into the R phase, representation, while most of your other students are in the C phase. So you're teaching a lesson and your class is now in two unequal groups. Some students are learning that lesson through the concrete. Other students are learning that lesson, that same lesson, through the representational phase. And then eventually some student is going to come up to you and say, really, do I have to keep drawing these pictures? And you say, well, do you have a suggestion? And the student will say, well, yeah, instead of me drawing all these pictures, can I just use numbers? Instead of drawing 8 cubes, can I just write the number 8? And you say, wow, that seems pretty lazy, but go ahead. And now all of a sudden, you're teaching a lesson and your students are now in 3 unequal groups. Some students have pushed all the way into the abstract phase with numbers and symbols. Some students are still in the pictorial phase, drawing pictures of, and the concrete, which some students are still in that concrete phase. So you have 3 unequal groups. The key thing is, as time is ticking, each lesson I'm teaching, I'm only teaching one lesson. It's just that the students are self-differentiating into one of these 3 stages of development: concrete, pictorial representation, or abstract. Eventually, students are going to always be seeking out the phase of development that is most effective and most efficient for them. And so those concrete kids are eventually going to wean themselves of the concrete, and you're going to now have just 2 groups, the R and the A. Lastly, those R students are going to wean themselves of the pictures, and they will graduate just to the same abstract. And we call this the arc of development. Over time, you start with probably a single phase of development, but then their students differentiate automatically as they are able to, and then eventually you will end with that whole class being firmly in the abstract phase. Now, this timeline can be days, weeks, months, even years. It depends on the topic that you're teaching. Some lessons, some topics might begin the week on Monday firmly in the concrete, but within a day or two, students are already in the abstract. At the middle school level, an example of this is adding negative numbers. It's pretty quick. This arc of development is a pretty quick timeline with adding integers, generally 2 or 3 days as you move from the concrete all the way to the abstract. Other topics, algebraic equations might take weeks. One arc of development, long division, takes about 3 years. It begins in the concrete phase in 4th grade, and it doesn't end in the abstract, fully in the abstract, until 6th grade. So that's another connection to middle school. 6th grade long division, we will get to the abstract. However, we as 6th grade teachers may have to teach our lesson fully cognizant of the fact that some of our students are still in the concrete phase, some are still in the pictorial phase, some are still in the abstract phase. And our goal for long division in 6th grade is to get students firmly into the A, that abstract phase of development.
As middle and high school teachers, most of the concepts that we're teaching are building off of the concepts that students learned in elementary and middle school with concrete and pictorial representations. So we see a lot less concrete and abstract or concrete and representational work in high school, but we need to remember that especially working with students with disabilities, students who have had, missed opportunities for hands-on instruction because of virtual learning, we are going to have a lot of what he's talking about here, students in unequal groups that have different needs and understandings. And I love this video because he does such a great job explaining how students can move through the phases at different rates. Now, just to clarify, even when students are working in the concrete phase, they still may be using the procedure and writing the procedure, but they're dependent on the concrete manipulatives to support them through the procedure. It's almost like the procedure is a note-taking tool for them to use as they work out the problem with the hands-on materials. The same can be said for drawing a picture. The picture is where the solving of the problem is happening and all of their thinking is being worked out, but they're recording how they solved it by writing the math symbols or the equation alongside their picture. And that gets the multiple representations going, and that's how they progress through the different representations until they no longer need the extra support from the manipulatives or the picture. With all of that said, how do you know when your students have really solidly gained an understanding of one step and are ready to shift towards the next stage in the progression? In the video we just watched, the presenter described students self-identifying, basically saying, hey, I understand this at the point where I don't really need these manipulatives. I don't need to draw a picture. I understand this enough where I can just write the procedure down and write the numbers down and understand it and get the right answer. And if your students are verbalizing that, that's great. It's a great sign that they are moving towards the abstract. But when your students aren't doing that and you need a better understanding, you can use formative assessment to help find out what supports they need, help you group the students into the right groups so that they can give each student the right support that they need or each group the right level of supports. And it's pretty straightforward to do that. A great informal and straightforward formative assessment you can use is just to observe your students while they're working to solve the problems, allowing them to use the concrete or draw a picture if that's what they need, whatever they feel like is best for them, and then listen as they explain their thinking to solve the problem. This is the tie back to the formative assessment piece that we discussed in the first part of this session. Using observation, you can formally assess your students and see where they are in this progression. When you're observing, what are you looking for? Well, you're looking for how well students are able to use either the concrete or the pictures that they're drawing to answer the math questions. If you give students concrete manipulatives, you'll know that they have a full understanding of the concept when they can fluently use the manipulatives to solve the problem and they can explain how the manipulatives are helping them get the right answer. So if they can just fluently, like, here's how I solved it, this is how the manipulatives worked, you know that they're getting closer to not needing those manipulatives anymore. Similarly, they can draw a picture fluently. Okay, I know what picture I'm going to draw without getting confused or stumbling on the picture, and they can explain how their picture is related to the problem or the procedure that you're teaching them, you know, the algorithm that you want them to use. Then they're ready to start decreasing their reliance on the picture and move more closely and firmly into the abstract phase. Because each of the concrete and pictorial phases should mirror the procedure, being able to explain how either the manipulatives or the picture solve the problem is a really big, key, important part to becoming fluent in that math procedure. So instead of memorizing the procedure, memorizing the steps or the algorithm or the equation that they're supposed to use, they intuitively know how it works, and there's less of a dependence on a formula and memorization and a really solid understanding in what's going on in the formula. There are some simple tools that you can use to keep track of your students and how they're progressing. In this tool, which you can use while you're observing students, you simply put a check mark next to the C, R, or A for each student once they've mastered the content that you're teaching at each stage. So as an example, if you are teaching solving multi-step equations in algebra, you can observe students using algebra tiles and have them describe how the algebra tiles prove the answer to the equation. And students who are able to fluently do so would be ready to decrease their use of those algebra tiles. So you'd put a little check next to the C, they've mastered that, and they're ready to start using some pictures and drawing their explanations. And once they're able to really explain their pictures and quickly and fluently draw the picture without getting tripped up, you can say, all right, it looks like you're getting ready to move just to using the mathematical symbols and the procedure to solve it. You don't really need these pictures anymore, but they always have the picture. They can go back to drawing a picture if they get tripped up on a tricky question. This type of checklist makes it super easy to sort your students at a glance. You can just look down and see who needs what types of supports, and it makes it very easy to group and provide the right supports for your students. I want to make the point again that you're still having students write the equation even when they are using the concrete or drawing a picture. That's how you make the connections, but you know that they still need that picture or they still need those concrete manipulatives until they are fully able to explain what they're doing with the manipulatives quickly and easy and fluently. If you could walk away from this training with just a few key ideas, the first would be that students really rely on their conceptual understandings of math concepts to use the procedures that we teach them in math. And that CRA can really help achieve both of these goals for students. It can help really solidify the concept and the math content you're trying to teach alongside and support the use of the procedures that we want to see them using so they can quickly find the answers. And the second key idea is that formatively assessing your students is going to help them and help you provide better instruction in the concrete, pictorial, and the abstract representations that you want to teach. Walking away from this, we want to challenge you to use at least one formative assessment daily in your classroom, and you can use the resources in this website to help you do that. So there are many resources, one of which is 60 formative assessments that you can use, and there are short descriptions and supports provided for each of them. So check those out, and we challenge you to start using more and more formative assessments in your class.